Ahoy, welders! Here we go again, another semester. Buckle up. Aren't you really excited? I am. I love welding. I hope you do too. We're going to have lots of fun, some of which will be in a classroom in the lectures, and some, and even more fun when we get into the lab, where we'll be conducting, experiments and projects. However, most of you will be, most of what you're going to be doing is practicing. If you want to get good at welding, you need to practice. You got to think of it like you're playing a guitar or a piano or math. The more you practice, the better you get. Keep that in mind as you go through the various welding courses. First thing we always do in any welding course is talk about safety. So let's talk about safety stuff. There's a we in each class, before you even get into the lab, you have to take a test, right? So you've probably been given that test already. So let's make sure that you get 100% on it, because it's all important that you understand all about safety for welding. So there's a document at the AWS, American Welding Society. So I want you to go to aws.org/standards/page/safety health facts sheets. Now there's hyphens in between safety-health-fact.sheets. So there's a whole bunch of modules in there. There's a list of modules. It's free. This stuff is free. So, we used to have you do SP2. Some people make you do OSHA. But this one's free from the AWS. So go there, and I'll post this in Canvas. But if you go there, it's like a OSHA training for welding. It's specific to welding, so it's pretty good. There's a bunch of modules in there. It's going to take you some time to get through it, but take your time and try to cover all of them, all those little modules in there. So you should definitely check them out as best you can, and try to get that done through the semester. It's just a lot of good information in there. Like I say, I'll post it on Canvas with those links. So some also good advice is I've posted hundreds of files on Canvas. You should think about getting a thumb drive, plug it in, and copy those files and put them in your tool bucket. So you should seriously think about downloading those files from Canvas on your thumb drive, because you're going to need that stuff one day. It's like getting a free textbook. In fact, there is a textbook on there that I've listed. It's a free textbook. It's an old one, but it's free. But anyway, or you could go to Amazon and buy a textbook that's a couple of years old to save some money. And if you want to know a good one, come see me, and I'll help you out with that. Some people suggest that you get this How to Weld by Motor Books. It's published by Motor Books, and it's got lots of pictures in it. So it's pretty good. It's a real basic kind of high schooly looking textbook, but covers pretty much all the welding you need. By the way, the school is giving out laptops and Wi-Fi hotspots. So if you need one, go there, check them out. Check it out over at Student Services. Okay. There's a couple of documents that I want to make sure that you get a good grasp on. One of them is the grinder safety lecture. If you go to YouTube and type in the search in the search bar, grinder safety, the words grinder safety. The first one that comes up will be weld.com grinder safety with Redbeard, Jason, over at weld.com, and he'll show you everything you need to know about the grinder, the 4.5-inch grinder. It's the best video out there by far on grinder safety. Also, things like in the lab, if you haven't been checked out on it, then don't touch it. The bandsaw, cutoff saw, the shear, and other equipment in the lab is off limits until you've been checked out on it. Anyway, the first rule of safety, of welding safety, is safety glasses. You know, there's a lot of sparks. These are $2 from Harbor Freight, right down the road, and so you know, they scratch easy, so get you a few pairs. But there's a lot of sparks flying around. If you don't want to die from eye cancer, if you get something in your eye, you know, if you get something in your eye, get a rust ring. If it's a carbon steel, you'll get a rust ring in there. The eye doctor will have to scoop it out. So it's like a melon scooper looking thing, right? And if you leave it in there, that rust can get in the back of your eye and go to your brain. You get brain cancer and you die. So wear your safety glasses at all times, protect your eyes so you don't die from brain cancer, eye cancer. All right, the second rule is to assume, you have to assume that everything in the shop is hot. Everything in that lab is hot, okay? So don't pick up anything with your bare hands. Always test it first to make sure, see how warm it is before you touch it. Try not to burn up your gloves too. You know, your gloves will get all crispy and crunchy and hard if you pick up hot stuff. So try to protect your gloves as best you can. You'll find out the price of gloves soon enough, because they do wear out. But and I'm guilty of that too. I'll pick up stuff that's a little warm with my gloves sometimes, but I don't do it very often. Anyway, so I don't want anybody getting burnt in the lab or getting cut with the grinder. So safety is a big deal, and that AWS document and those safety modules will certainly help. So I have to assume that most of the pipe welders have already been through the introductory classes: blueprint reading, AWS welding symbols, metallurgy, welding math, etc. That's all in my canvas as well. But as pipe welders, we live by a different set of codes, and you know the world is mostly made up of square stuff like plates and I-beams and stuff. There's a lot of stuff out there called pipe, right? And that's pipes and tubes, and that's where we come in. We'll be going over a different set of materials, such as how to read piping blueprints and the ISOs, you know, piping symbols, piping fabrication, process piping, structural piping. Pipe and tube are two different things. All this stuff is really important to you as a pipe welder. And then, of course, I want everybody to be able to take a certification test, hopefully by at least by the end of the semester. There's no reason for you to come into the lab and work really hard and throw a bunch of ugly welds out there and expect me to get you certified. That's not going to happen. If your welds have to look good, right? So you need to learn how to run a straight bead. You need to know how to make a good profile and make them look good. Normally, if the welds look good, they have a higher degree of probability of passing the bend test. And so by now you should already have know something about all the defects and discontinuities and how to troubleshoot and how to avoid problems in the welding and how to troubleshoot. All right, so you should already know all that stuff by now. If perchance you're having trouble welding ugly stuff, then that's what I'm here for. I can help you overcome ugly. This is not a fashion statement. It's not a subjective thing. If you read Plato, he'll let you know that you're looking for perfection, right? So, and harmony, he says harmony. Anyway, I can help you overcome this ugly, and because it's either going to pass, well, first of all, it's got to pass a visual inspection, so it's got to look good. And then if it looks good and it bends, or x-ray, that's good. Then you're past your goal. So why do you want to do that? Because you want to make sure that the ship's not going to sink. You want to make sure the bridge is not going to fall. You don't want to make the nuclear plant blow up or explode due to a bad or faulty weld, right? You don't want the airplane to fall out of the sky. And what happens if you're on the space shuttle or the mission to Mars and a meteorite hits your spaceship and you need to fix it, right? So you go out there with your TIG torch and weld it up. You don't want it to blow up or you don't want to die in there, right? Okay, so two things we're going to be doing in the pipe welding class. 6-inch, we're going to be practicing for a 6-inch carbon steel pipe with the open root using 6010 electrodes for the root and hot pass, and 7018 low hydrogen electrodes for the fill and cap passes. It's a very common size pipe and weld process. The best way to learn this is practice on the bevel plates first. When you can put a root pass in a plate, on a bevel plate, then you can do it well with no stops and starts showing, no undercut, no overlap, no flag inclusion. It looks good all the way up and down, inside and out, then you're gold, right? So don't forget your overhead stuff. You kind of start off in the horizontal with 2G. It's a little bit different thing. Most people don't practice that, but it's a good way to get started, learn how to put their root pass in on an open butt V bevel. So just so you know, most folks usually have trouble in the vertical position when they first get started with open root welding. It is probably where most of the trouble is, but then once you get good at that and you begin tilting it backwards from a vertical position to a 45 position, and then working your way towards an overhead position, right? This makes sense. That's a natural progression, because that's, hey, you're going to go around the pipe, right? All right, so this is where like welding the bottom of the pipe and where most people begin having trouble. Once you get to the top, then gravity starts to help you when you're welding in this position around the top of the pipe. So when you get good at plate, and then we want you to start on pipe, and so once you get that perfected, then you get certified with the 6-inch 6010 root and 7018 fill and cap. The other pipe that we want you to practice with, hopefully, a lot of people don't have time to do that, but sometimes if you get that 6-inch done, then maybe start working on a 2-inch carbon steel pipe using TIG. All right, so why do we do both 6-inch and 2-inch TIG? Because most of the world is made up of those two items. If you can weld those good, then you should be able to take care of other size pipes and other thicknesses of pipes. And then you'll be a super good welding student, okay? So, you just have to remember that it does take a couple of years no matter what you're doing. If you're going to be a lawyer or a doctor or a welder, it takes a few years for you to become a master at what you're doing. So what you'll be doing is learning a lot of stuff in the laboratory. And the laboratory is where we experiment, right? So I want to encourage you to experiment with all these welding processes, and even much more than, there's a lot more stuff that I can make available to you, and you'll see some of that stuff in Canvas. That's why I encourage you to download that, so you'll have it and wherever you go in your welding careers. And notice that I said plural for careers, because guess what? You're probably most likely not going to stay in one place forever, which means you want to absorb as much as you can while you're here so you can be exposed to as much information as possible. Our motto in this class is never stop learning. Okay, that's about all I have to say about that. So I'll see you in the lab, and we'll have fun. All right. Bye-bye.